Good day, everyone, and thank you for attending this talk about attacking web applications with browser DevTools. Before we get into the topic, let me give a quick intro about myself. My name is Ziad Al-Madani. I'm from a small and lovely country called Bahrain. I'm a training content developer at HackTheBox Academy, currently working on the Bug Bounty Hunter Path web application penetration testing modules. And I'm mostly focusing, in addition to web application penetration testing modules, on white box pen testing, code review, and binary exploitation. So go look up these modules and hopefully you like them. And I also like to do some development side projects. Currently I'm working on two projects. The first one is a mobile app using the Flutter framework for iOS and Android. And the other is the Nmap Automator project. You can find it in GitHub, which should make website reconnaissance very easy and makes it super automated. Getting into the main topic of this talk, today we will be talking about web application penetration testing. Now, we will go through three different demos, live demos. The first is cross-site scripting demo. The second is insecure direct object referencing. And the third is a file uploads exploitation demo. All of these are parts of modules that are in the Bug Bounty Hunter path at HackTheBox Academy, which you can go right now and take various modules in and complete the entire path. So the twist we will be putting about these demos is that we will only be using the browser. So we will not be using any external tools. We will not be using any operating systems like Parrot or Kali, or tools like Burp Suite or Zap. No, we will only be using the web browser. And this is a great skill to have in our web application pen testing arsenal, because in some occasions we will not have any access to special tools for performing web application pen testing, and we need to be able to perform the tests using whatever tools we have. And what tool is always available for web applications? A browser. So being able to exploit this web application using the browser and its built-in dev tools can be a lifesaver. And sometimes the dev tools are mainly intended for web developers, for controlling their front-end code and testing, various requests into the backend servers. But we can use them as web pen testers, and they can be really powerful, as we will see. So let's start with the first, XSS or cross-site scripting. You can go to the module for full technical details on these, but basically XSS is an attack that happens when a user input is displayed directly on the page, on the web application page, without actually being filtered. So if we just use script tags, HTML script tags, and put JavaScript between them, theoretically, the browser would actually execute our JavaScript code, and we would be able to carry various attacks like defacement, phishing attacks, or even session hijacking on the target users. Like I said, the main mistake being happened here is taking unfiltered user input and displaying it right on the page. So let's go to HackTheBox Academy, to the Bug Bounty Hunter path, and we see all the modules that we will be covering. And the first one we will start with is the cross-site scripting module, which is right here. And let's see how we can use this attack to cause a defacement on a web application. Now, what is defacement or defacing? We see that many hacker groups actually attack websites and change the look of this website to say that you have been hacked by this and that group and so on. And this is called defacing, basically changing the face of the website. And defacing attacks are not always caused by taking complete control over the backend server. Now, when you go to a website, let's say a government facility or a banking website or any other web application, and you see a deface and says you've been hacked, some people might think that they have got complete control over the backend server and they have access to all user details. This might be the case, but this is not necessarily the case, as we will see this time. Having a stored XSS vulnerability is enough to deface the website. We can change several elements in the page. The first, for example, is changing the background color. The second is changing the page title, which shows up right here in the tab. And the third is actually changing the HTML text or input of the page. Let's start by changing the background color. Now, this website is showing a white background color, and we try to change it to, let's say, this color of this Academy web page. We can click on Control or Alt and I, and it will show the page inspector. And we can click on this inspector tool and just hover on the page and click on it, and we would see on the CSS style page all the various CSS components applied to the page, and one of them should be the background color. Might not have shown here, we might not have clicked on the proper page, so let's click on the whole thing and we see it right here. All right, so we can just take this color and use it in this payload document, which is a JavaScript function, document.body.style.background equal this color. Let's copy it and input it, and once we enter it, we see that the page changed its background color, and this is not something temporary, it's actually persistent. We can just click on it and we see that it persists through refreshes. Now let's try to change something different, like the page title, as I mentioned earlier. The payload we have in Academy shows us how to do so by using document.title and equal whatever text we want to input. Let's say we want to say, you've been hacked, question mark or exclamation mark, and hit enter, and we see that the title actually changes to you've been hacked. Now let's go into the juicy stuff and try to change the entire content of this web application page. To do so, there are several things we can use, but the most efficient thing to use is using document.getElements by tag name, select body, the first one, and then change the inner HTML. To understand this, we can just click on Option, Control, and U, and view the source. And we see that it's the HTML page starts with a head and then the body. And in this case, we would be selecting the body like we did 0. So it's the first body, not the second body. And then we would be changing the entire content of the page with the inner HTML. We can test this before actually changing it permanently, and maybe we lose this functionality to inject into the page. So we can once again click Alt, Control, and I, go to console, and then use it right here and say test. Now this will be temporary because we are using the console. We click enter and we see test right here. If we refresh the page, it should not persist because we only use the console. Now this is handy, very handy, so we can test how the page would look before actually committing to the final HTML text that we want. So what kind of content should we put? Here in the module, we have a sample HTML text that we took actually from the Academy main page. We can just go to this main page. We can just click on Control Option or Control Alt and I and select this bit. Okay, let's select both of them. We can just go right here and right click on it and select Copy Inner HTML. Now we can close this and go back to our vulnerable web application and input the XSS payload. So we said between script tags we would do, as mentioned here, document.getElements by tag name, then specify body, and be sure to select the first one, .inner HTML equal, and we will input whatever text we copied earlier. And we see that it still ends with a tag. Let's just make sure that, because we are between single quotes, let's make sure that we don't have any single quotes. I don't see anything here. All right, and so theoretically, once we input this, we should replace this look with the look we just copied from the Academy page and hit enter, and indeed we get the look. Now we might be missing the CSS styles because we have to import the CSS style, but I'll leave that as a challenge to you. You can use JavaScript to import the CSS style from the Academy page and make it look exactly like this. We can also follow whatever is mentioned in the module to achieve the same result. And this has been an example of basically being able to attack this web application using nothing but the web browser and the web browser DevTools. We have been able to copy HTML input from one place, test it on the web application, and then use it in our XSS payload. Now let's get into something a little bit more interesting, which is IDOR attacks. Now, IDOR stands for Insecure Direct Object Referencing. In many places in web applications, we would see it referencing an object like question mark receipt equal 1234, and this would be your receipt after making a purchase. So what would happen if we just change the URL to receipt question mark receipt equal 1235 or something? Would we be able to get the receipt of another customer? And in many cases, this is actually the case. And many web applications have this vulnerability because it is often difficult to secure unless the web application developers actually have a good control over the backend system. They have a very solid access control system, like having an RBAC, a role-based access control system. And if they aren't aware of such vulnerabilities like IDOR, or if they do not have such controls on the backend, they will not be able to prevent such vulnerabilities. And there are various ways to prevent this vulnerability as shown in the module. But let's go back to the module. Let's close this very quickly and go back to this web attacks module in HackTheBox Academy, part of the Bug Bounty Hunter path, and go to the bypassing encoded references section. We see the details in the section, but let's go to the end and just spawn the target. We have it right here. And if we take a look at what's mentioned in the section, it says that once we open the web application, we will get the employee manager web application, and then we can click on the contracts functionality to get to this page. And it would actually show us our contract. And once we click on it, it would actually download our employee contract. So let's try to test this. We click on the page. It may take a little bit to run. We refresh the page and we see that it's actually here. Make it a little bit bigger as well. And we see the employee manager. Click on contracts, click on our contract, and it indeed gets downloaded. If we try to take a look at what's happening, we can go hover over the file, and we see at the bottom left, it says JavaScript download contract 1. So what we want to do is to examine what network requests are being sent through this web application. So we can go click on, once again, pop up the DevTools with Alt, Control, and I, go to network, click delete to delete everything. Make sure to click persist logs so we don't lose anything if the page gets refreshed, and then click on the link again. We get the file and we see this link being sent. If we click on it, we can actually see the entire request, its headers, and we can view any content that it had. It doesn't have any content in this case. The response is basically the file. So we can see the content here. So let's try to see how this page is calculating the hashes or the encrypted values to be able to send them here. We see that the return file is named contract and then some hash and then PDF, but the request itself just contained contract equal this value. This is obviously not our UID or something, but it's some encoded value. It appears to be a base64 encoded value, but let's see how this is happening. We can go back to the inspector, close it and just open it again. Click on the page inspector or element inspector, and then select our element. Now, when we get to the part of the HTML code that actually refers to this part of this link, we see it calling JavaScript download contract to be able to actually download the file. Now, let's try to see what this function is actually doing. We can just double click on it right here, copy its name, go to console, and just paste it, and we can click on this button in Firefox DevTools. Some DevTools like Chrome or Safari would actually print the function, and so in Firefox we can just click on it and jump to it. And when we see this function, that it actually what it actually does, it says window.location, so it's changing the actual URL of the page, and it's taking us to /download and then contract, and then specifies this value. Now, what is this value? This appears to be encoding URI component, which is basically URL encoding, and then doing B2A UID. B2A is Java is the JavaScript function for base64 encoding, and it is actually encoding our UID, which is 1 in this case. So we can go to the console again and do v2a, same function, and pass it number 1 as a string, and it would actually be matching the string we found earlier when we clicked on our link. Network, click on it, and we see this value right here. And we click on it, and it actually downloads the page. So we see it right here, and this actually matches the value we just got in JavaScript. Now let's try to change this value to another user's UID. Let's say user number 5, and we get this value. So let's go back to our function and try to copy the link that it refers to, /download/contract, copy it, and just use it as a link here, equal this value. And we see if we actually get a file. Enter, and we do indeed get another file. Now let's try to input just any random value, and we get file does not exist. So we are actually able to obtain another file. Now we can repeat the same thing by just doing any other user UID like 10 or 1, and we would actually be getting the encrypted values or the encoded values to be able to obtain this employee's contract. Now this is a basic example of how we can use IDOR vulnerabilities with browser web tools, browser dev tools, to be able to exploit this basic vulnerability. In the module, we see more advanced examples of how we can actually exploit this IDOR vulnerability and bypass various protections in place to be able to actually reach the same result on obtaining other users' files. The final attack we'll be covering today is a file uploads attack. Many web developers make the mistake of allowing arbitrary file uploads to their web application when they use a file upload form. Now this can lead to remote code execution and gaining complete control over the backend server. Some of them make another mistake by allowing some dangerous types to be uploaded, like SVG or XML or JavaScript or HTML, and not filtering these types. And this can also lead to other vulnerabilities like stored XSS, the one we saw earlier, XXE, denial of service, and many other attacks. And the final mistake we will discuss today is making or placing the validation of what files are allowed to be uploaded on the client side. Now, some web developers might actually only allow like JPEG images or PNG images or only images, but they would keep this file type validation on the front end and the client side, and this can be bypassed, as we will see now, through various techniques that we will demo now. If we go to the file uploads attacks module in the bug bounty hunter path, and we go to the client-side validation section, we can actually see this demo. We can just go to the bottom and just spawn our target, copy it, and while it runs, we can just go quickly through what this attack is actually showing. We would see a web application that is allowing us to update our profile images. Now, this is very common in many applications like social media web applications or any employee manager. They would usually allow us to upload our profile image. Now, if this functionality is not secure, we might be able to actually exploit it to upload arbitrary files to the backend and gain remote code execution. In this example, we see that let's make this a little bit bigger again. When we click on it, it would actually prompt us to select a file. And if we select an image and upload it, it should be able to upload. The thing we see that when we click on options, it says supported type are JPEG, JPEG, and PNG. And if we upload any other files as shown in the module, it says only images are allowed. So there is some form of control that is denying us from uploading arbitrary files. To try to test this, let's go to Academy or HackTheBox.com and download any random image like this one, save it, and if we go to click on the profile image, we can select this image and click upload, and we will see that it actually gets uploaded. If we just refresh the page, it persists. So we are actually able to upload images. Now let's see if we can upload any other types, like does it allow uploading PHP files? And let's just download the same image. This time just name it all files and just name it image.php. interactive.php. Yes, use PHP. And this time, see, we cannot select it. This can be easily bypassed because we can just go here and select all files like we did just now and just select the file. And then we click upload and it says only images are allowed. Now, is this validation happening on the front end or on the back end? We can quickly guess that it is actually happening in the front end because it happened really quickly. It didn't take some time to refresh the page or send a request. It happened instantaneously. We can verify this by going to the DevTools again, going to the Network tab. We can clear everything and make sure to persist the log, and then select a file again. Just bypass this, file type limit, and then select our PHP file, click upload, and it says images are allowed again. We can just refresh the page and do the same thing just to be sure. Just clear this. Allow all types or files, select it, upload. We get the message. We don't get any requests in the network. You just saw a little bit earlier when we refresh the page, it actually sends various requests. And now it is not sending anything, meaning that this validation is actually happening in the front end. Now let's confirm this by actually viewing the source code of this button that is actually allowing us to upload a file. When we see it, we see that it says accept these types and on change show image. And if we go above it a little bit, it says on submit if validate upload. So what is validate and what is upload? Just like we did earlier with the XSS, we can just copy the name of the function, paste it here, and go to it. And we see this function, validate. What is this function doing? It says it specifies the file type that is being passed to it, which is whatever file we selected. And it says if its extension is not JPG, JPEG, or PNG, it would actually show an error message, the one we showed earlier, only images are allowed, and it would reset the form and disable the upload of the file. And what about the other function we just saw? If validate, so if it is valid, it would actually upload. So let's see this function, upload, go to it, and it is the function at the bottom. And it appears to be sending an AJAX request to the upload PHP web page, and then it would just reload the page after uploading the file. And it would actually be using the file we selected. So what we can do to bypass these client-side controls is we can actually, using the web page inspector, we can actually change the front-end code to remove them. For example, we can just go here on accept and double click on these types and just remove them. And it should now allow us to select any file types without any limitations. And we can see that we don't have to select options and all types. It actually went through and we can actually select it. Now, the other thing is on submit, if validate, do upload. We don't want to do if validate. We just want to do upload. Just remove it, click enter. And now we should be able to upload our file without getting this message. And when we click on it, we see that our file might has actually been uploaded. We view the page and it says actually interactive.php. So even though it's an image that we downloaded, so it is showing here as an image, it actually uploaded a PHP file. And this can be very malicious and very dangerous if we can take control of this vulnerability and exploit it. Let's go to Google and just search PHP web shells. And let's say GitHub. And we get various web shells that we can just select any one of them and use. One really useful web shell that we can use is by our fellow HackTheBox colleague, Araxel. It's called PHP Bash GitHub. And we can go to it. It's GitHub repo, and there are two scripts, PHP Bash and the minified version, php.min. Let's go with this one. We can click on raw, and we would see the source code, the PHP source code of this page. Let's try to save it. Save page as, and it says text file. Let's just select all files and then name it phpbash.min.php. Save. Now let's try to upload this file again. Once again, we would just select the image, remove any file type, remove the validate function, which is the client-side validation that is happening with the file type. Now we should have no validation. We can just click on it, select PHP bash, upload, and the file appears to have been uploaded. We can view the source again, click on it, and we see the link of our file right here. We can just control and click it, and it will actually take us to our web shell. We can interact with the backend server, we can go back a directory, and we can have complete control over the backend server by simply bypassing these front-end client-side controls and being able to upload any arbitrary file. We still have one last trick that we want to try. In some cases, these client-side controls might not be the only thing that is preventing us. There might be some backend controls that is happening, in which case we would have to actually intercept our request through a tool like WebSuite, and then try to modify the request, the HTTP request that is being sent to the backend, to try to various bypasses. Now, is this possible with browser web tools? It actually is possible. We can go to the network, click everything, clean everything, and just make sure that we have persist logs. Let's try this time to upload any normal image. To get the normal image upload request, click on it, click upload, and we get the request right here. We can click on the request to view it, and we see that it says content type, and it specifies various headers that the form is sending. We can go to the request itself and see the content of the request, which is the binary data of the PNG image we selected. Now, is it possible to actually intercept this request with the browser DevTools? It is actually possible, but an easier way is to just right-click on this request and select copy as fetch. And fetch is a JavaScript function, so it will copy it as JavaScript code. Then we can go to console, which executes JavaScript code, and paste it, and we would get our request right here, which we can send again or modify however we like. Now, I'll leave the details to the module, but we can just go to the image itself, the binary data, select the beginning of it, and all the way until the end, delete it. Now we can input any data we want. So we will input a very basic PHP web shell. We can just go to the cheat sheet from the module and select this basic PHP web shell. Go back to our web application, and right here we can actually, where is it? Yep, just delete it again and paste it right here. Now we have the PHP code instead of the image content. We should also change the file name from PNG to a PHP file, so it can be considered and executed as a PHP file. Let's call it shell.php. And let's send our request. Now let's refresh the page to see if our request actually was sent. And we see that the image doesn't show this time, and it appears to have been sent. We can click on it, and we see that it actually says the link of, shows the link of our uploaded file. We can control click on it, and we don't get something like file not found. We get actually the blank page of this basic web shell, which we can pass commands to with the cmd parameter, cmd equal, let's say ID, and we get code execution on the page. We can say also ls. And a final tidbit, if we do something like ls plus -la, plus is just the URL encoded version of space, we get it like this. And we want to view it as as it shows in the web shell or as it did here. We can just click on Control U, and it would actually show us the source code view, which always matches the raw format, which in this case is a shell output format. Now, this has been the file uploads attack using the browser DevTools, and this has been the talk. I hope you liked these demos, and I hope you liked the exercises that we showed and how we can exploit them using nothing but the browser DevTools. You can actually, we have just scratched the surface of browser DevTools. If you learn more about browser DevTools, you can actually perform various other attacks, and the majority of the attacks that we actually perform in the bug bounty hunter path can actually be replicated using only browser DevTools, and we show a lot of that in the bug bounty hunter path. So thank you everyone for attending this talk. I hope you found it interesting and beneficial. You can go to HackTheBox Academy to the bug bounty hunter path and learn more about each of the attacks that we've shown today, and learn some of the advanced tricks that we show, and learn about various other topics and web application tests, pen testing topics through various other modules. Thank you, everyone, and have a good day.